Hi dear students, welcome back to BS Academy. We are now discussing about the chapter 1. Today in this class we are going to discuss about the derivation for electric field. So in the last class itself we have discussed what is meant by electric field, and we discussed what is the direction of the electric field, and for a positive charge how the direction will be, and for negative charge how it will be. So all those things we have discussed in the last class itself, right? So we have already found the equation from the definition of the electric field. So let us recall that equation. What is that? E, that is electric field. Electric field is defined as what, students? Electric field is defined as the amount of force experienced by the unit positive charge. Okay, so E is equals to F by Q. So electric field is defined as the amount of force experienced by the unit positive charge, that is Q. So this is the basic equation for the electric field. Now we are going to derive the equation for this electric field. So for this, let us recall about the force, amount of force that we have already derived under the Coulomb's law. So see, according to Coulomb's law, what is the equation for the force of attraction or repulsion? F is given by Q1 Q2 by 4 pi epsilon naught r square, and if it is in vector notation you have to include r cap. So F is equals to Q1 Q2 by 4 pi epsilon naught r square into r cap. So here in this Coulomb's law we have discussed that we have considered the two charges as Q1 and Q2. But for here, for electric field, you can consider this Q1 as capital Q and Q2 as the small q. That is, capital Q is source charge and the small q is test charge, right? So we can replace this Q1 Q2 as capital Q, Q1 as capital Q and Q2 as small q. Q, where capital Q is the source charge and small q is the test charge, divided by 4 pi epsilon naught r square into r cap. Okay, so this is the equation for the force. So we have to substitute this equation in this basic equation for the electric field, so that we will get the equation for electric field E. So right, we will substitute this equation. So consider this equation as 2 and consider this equation as 1. So see, substitute equation 2 in 1, right? So what happens? See, E is equals to QQ by 4 pi epsilon naught r square into r cap. This is the value of F. So divided by Q, no, the whole divided by Q. So the whole divided by Q. Okay. So see, so this Q is in denominator. So we can cancel out this small q. We can cancel out this small q. So what is the remaining thing? Then E is equals to capital Q by 4 pi epsilon naught r square into r cap. Okay children, so this is the equation for the electric field. So E is equals to Q by 4 pi epsilon naught r square into r cap. When we are denoting this equation in vector form, we have to include this r cap. So where capital Q is the charge, that is source charge. We know what is epsilon naught and r, everything. So E is equals to Q by 4 pi epsilon naught r square into r cap. So this is the derivation for the electric field. Is it clear, students? See, let us again discuss about this derivation. We have already know E is equals to F by Q, that is from definition. So electric field is equals to force, amount of force experienced by the unit positive charge. Okay, so consider this equation, and in this equation we have to substitute the value of force. So for that we are again writing the equation of the Coulomb's law. So from Coulomb's law, that is according to Coulomb's law, F is equals to Q1 Q2 by 4 pi epsilon naught R square into R cap. Now in Coulomb's law we have considered the charges, two charges as Q1 and Q2. Now here we can replace this Q1 as capital Q and Q2 as small q. Because for electric field we have considered the charges as capital Q and small q. So where capital Q is the source charge and small q is the test charge. So replace the Q1 Q2 as capital Q and small q, so that you will get F is equals to Q into Q by 4 pi epsilon naught R square into R cap. Consider this as second equation. So substitute this second equation in this first equation, so that the equation becomes E is equals to QQ by 4 pi epsilon naught R square into R cap, the whole divided by this Q. So we can cancel out this Q which is in the numerator and denominator. So therefore the remaining equation is E is equals to Q by 4 pi epsilon naught R square into R cap. Is it clear, students? Yes. Now see what will be the direction of this electric field. The direction of the electric field will be, it will be outwards for the positive charge, and the direction of the electric field will be inwards to the negative charge. Okay, because we have already discussed the source charge may be of the positive or negative. So this is the point we have to note down. So this is note. This is important point. So the direction of E, the direction of E, that is electric field, is away from the charge, is away from the charge for positive. Okay, for positive it is moving away from the charge. Then the direction of E is towards the charge. The direction of E is, the direction of E is towards the charge for negative. Is it clear, students? So when we are finding out the direction, when we are finding out or deriving the equation for the electric field, we have to derive the equation. That equation will be the magnitude of the electric field. So there is, whereas we have to find out the direction also, right? Because electric field is a vector quantity. Electric field is a vector quantity, no? So it will have both magnitude and direction. So this equation gives you the magnitude of the electric field, whereas the direction of the electric field will move away from the charge for the positive charge, and if the direction of electric field will move towards the charge when the charge is of negative. Okay, students, so this is about the topic. Thank you.